Alright, so now we're going to actually evaluate limits analytically. This is actually very simple as long as nothing weird happens. As long as, again, none of these things happen. It's not piecewise, it's not undefined, it's not indeterminate. As long as everything is right with the math world, you can just plug it in. So in this case, let's look at this one. So we take the limit as x approaches 2 of x squared. So again, we have x equals, so we're taking the limiting values, so as x gets closer and closer to 2. But again, what's closer than equals? So we're going to plug this into our x value, and we're going to get 2 squared, which is equal to 4. Easy peasy. So what about, let's look at this one. Well, again, what is closer than equals to? So let's plug it in, make sure that nothing funky happens. So when we plug in this value, when we plug in x with -4, this would be equals to -4. Nothing bad happened. Life is good. Alright, in this one, if we have the limiting value, x approaches 2 of 3, well, there's no x for us to plug in. This actually is a horizontal line at y equals 3. So it's y, so f of x equals 3 anywhere. Doesn't matter. So does f of x equal 3 at 2? Yes. So it equals to 3. There's nothing to plug in. Alright, so we're going to go through a bunch of these questions. We're going to go through them really quickly because all it is plugging in. So example 2 from the book. Again, let's see what happens when we plug in x equals 2 into our function. So literally all you do for 2 squared plus 3. Biggest thing on here is you have to remember your order of operations, which you guys have been doing for a very long time. So this is going to be times 4. Plus 3, which is 16, plus 3, which is 19. So the limit for this one is 19. Easy peasy. Nothing weird happened. As long as nothing weird happens, you are good. Let's look at this one. Oh, this one has a denominator, which we have to be careful for. This denominator cannot be equal to 0. So let's see what happens when x is equal to 1. So when x equals 1, let's plug in 1. So it's going to be 1 squared plus 1 plus 2 over 1 plus 2. Well, this is 1 plus 2 plus another 2, which is 4, over 1 plus 2, which is 3. So 4/3. Pretty simple, right? Pretty simple. Okay, so this one we have here as x approaches 0. So again, as long as nothing weird happens, we're going to plug it on in. Plug it on in. So it's going to be the square root of 0 squared plus 4. Well, 0 squared is the square root of 4. 0 plus 4 is 4, which is equal to 2. This one's 2. And let's see, let's look at another one, cube root. Let's see what happens when x is equal to 3. So let's see what happens when x is equal to 3, as long as nothing weird happens. So we have here the cubed root of 2 times 3 squared minus 10. This is going to be 2 times 9, which is 18, minus 10, cubed root of it, which is equal to the cubed root of 8. So we're looking for 3 things that multiply to give us 8. So 2 times 2 is 4, times another 2 is 8. So this is equal to 2. Alright, pretty simple, right? Alright, this is our last set of examples. So x approaches 0. So what happens as x approaches 0? So we plug it in, So let's plug it in. Let's see what happens. Let's hope that nothing weird happens. so that we don't have to do any more math. Remember, indeterminate means we need to do more math, and if we can do less math, that's good in my books. So this is tangent of 0. Tangent of 0, so this is when sine is 0, which is, oh my gosh, why am I blanking? No, 0 degrees. Sine, let's bring our unit circle back over here. So remember, tangent is sine over cosine. Sine in this case is 0, cosine is 1. This is 0 over 1, which is equal to 0. So that's 0, yay, nothing weird happened. Okay, let's look at this one, pi. So plug in pi, cosine of pi. Well, let's look at the cosine of pi. So again, over here, cosine, remember, are x values. So this is going to be pi times -1, which is going to be negative pi. Beautiful, nothing weird happened. Alright, sine squared. Sine squared of 0. Remember, sine squared, this just means sine of 0, and you multiply it by itself. So you multiply sine by 0 times sine by 0. Well, sine, let's go to 0 again. So sine are your y values. So that means this is 0 to the second power, which is going to give you a 0. And that's it. This portion is the easy section of it. We're going to get into weirder stuff. So we're going to look at limits algebraically when things get a little bit weirder. We're going to look at some techniques that you can use when this doesn't work. So, but that's for next week. So enjoy your weekend. Hope this was a nice and easy lesson. All right, bye.